in this review we are going to study what we call the absolute convergence test. So let's write this as a theorem. So it's called the absolute convergence test. Convergence test, or in short ACT. So what is absolute convergence test is, so it says that if the absolute series converges, then this implies that the corresponding series converge. That's what it says. So if the absolute series converge, the corresponding series converge. So now the question is, when we're going to apply this one. So we're going to use when the series has negative terms. Use when the series has negative terms. So especially when you have sine, cosine, like trigonometric functions, you know that they fluctuate, so it may produce some negative terms. So that's a kind of one situation where we're gonna use the idea. So when you have negative terms, we can use this test. So let's look at some examples. So as the first example, we're gonna look at this one. So let's say sigma n going from 1 to infinity, sine cube n over n to the 3/2 plus 1, something like that. So what we can do, you know that the sine takes negative positive values, but this is odd power, so that means it can take negative terms in this case. So what we're gonna do, instead of this one, we can look at the absolute series. So we're gonna go with n going from 1 to infinity, the absolute one. So sine 3n over n 3/2 plus 1. So notice that sine is always in between. So whatever the sine function, it is always in between 1 and -1 when you have just the powers. So because of that, we can notice this also. Note that this is always less than or equal sine 3n over n 3/2 plus 1, which is less than or equal if you take the largest value of the top and the smallest value of the bottom. So you can write it like that. So this is true for n greater than or equal 1. So largest value at the top, the smallest value at the bottom. So then that's going to be largest. But what do you know? The corresponding, so we know that, but sigma 1 over n 3/2 is a converging P series with P equal 3/2, which is greater than 1. So then by the direct comparison test, the absolute series converge. Absolute series converges. Then by the absolute convergence test, the original series sine 3n over n 3/2 plus 1 converges. Okay, so the argument is very clear, but you can see that we take the absolute first, and then we saw the absolute series converge, and then after we saw the absolute series converge, actually for that we need to use the direct comparison test, along with the P series. So we use the P series here. So you can see that the P series is one of the powerful tests here. And then after we show that the absolute series converge, then we use the theorem here. Since the absolute series converge, original series has to converge. Okay, so you can apply this result for a problem like this one as well, even though the terms are positive always. So why don't you try this one? You can say n3 plus 1 square root, something like that. Okay. You can try these problems. It's very similar. Okay, so it's so when you have cosine sine, you can remove cosine sine using the using this trick because the absolute value of that one is less than or equal to 1. Okay, let's do one more example. So we're gonna do this one. So the next example is sigma n going from 1 to infinity, negative 1 to the n, and then negative 1 to the n over n 3 plus 1. Actually, you can show this kind of problem using alternate series test as well, but let's see how we use this one. So again, we can use this one, and going from 1 to infinity, the absolute one. But you can see that once you take the absolute value of the term, you can remove that negative 1 to the n term. So you simply get n over n3 plus 1 here, because these are all positive, so you don't need. And again, you can see that now, note that n over n3 plus 1 is less than or equal n over n squared. So you take the large same term from the numerator, now the and then this n3 actually smallest from the denominator, but you can see that this can simplify to n squared for n greater than or equal 1. Okay, again as last time, but you can say sigma 1 over n squared is a converging P series with P equal to, which is greater than 1. So so this implies that the original series this implies that the absolute series converges. Hence, the original series converges. Okay, so that's a simple argument. So here we use the absolute series. You can see how it goes through. We have that first, that converges, so this converge, that implies this one converges. Okay, so those are the kind of problems that we can do using the absolute convergence test or absolute convergence theorem.